My name is Hassellöv. I'm really happy to get the opportunity to come and meet the members of the Estonian expedition and to give a short presentation. I'm working in University of Götebourg, Department of Marine Sciences. I'm a marine chemist, mainly working with microplastics, you see. But today I'd like to make a short presentation about the combination of sailing ships and boats and ocean science in modern times. Does sailing research vessels play a role? I think that the Admiral Bellingshausen will itself answer that question in short time. But in addition to my affiliation at university, where we also started together with the Trondheim University something called Sailing for Science. It's like a grassroots movement trying to inspire this combination of ocean science on sailing boats and sailing ships. But as a side project, I'm also running a sailing boat for that particular purpose. So it will be a mix. Very interesting presentation about the Bellingshausen expedition. Of course, ocean science and knowledge about the oceans have been driven by sailing ships. And the first, considered to be the first global ocean expedition was the Challenger expeditions in the 1870s. Sweden actually had its first global expedition in the 1940s. With this sailing ship Albatross, which focused on deep sea sediment cores around the globe. And at that time, it was sailing ships was the standard. This is the Woods Hole Oceanographic Institution's sailing boat that was used until the mid-60s, actually. So, but that was the days. How about today? We'll come back to that in a minute. First, a little bit about the ocean sciences from the natural science perspective. Why do we need to care for the oceans in the first place? Well, this is a perspective of how humans depend on the oceans, of the seas. They provide a range of services called ecosystem services for us. Not only do the oceans cover about 70% of the Earth's surface, it's the majority of animal biomass is in there. It absorbs about 30% of the excess CO2 being emitted. It can produce up to 50% of the oxygen we breathe, and it provides about 17% of the proteins that we humans need for consumption. And it's huge economic benefits. It's an Earth thermostat. It provides a means of transportation, and also many new opportunities like minerals, medicines, and not least recreation. So we really need the sea, and it provides lots of these services to us. But we also need to care for the oceans. Otherwise, there is lots of threats like climate change, ocean pollution, destruction of the coasts, overfishing, and so on, that will degrade those services we depend on. So some gloomy view. I need to say that some animation about the state of the ecosystems in many places are going from a well-functioning state, many trophic levels, to a more, let's say, detrimental state of lower trophic levels like algae, jellyfish, and sprats, which we're not really that appealed by. Additionally, we have more of the ocean acid pollution, we have litter, we have increased temperatures, we may have risks from acidification and deoxygenation. So it's not looking very good in many places. But finally, some good signs that policy is starting to catch up. We have the Sustainable Development Goals with one, number 14, specific looking at life underwater. There's a number of policy measures now to better govern the ocean environment and to reduce pollutions of all kind, trying to regulate and have more sustainable fisheries, for example. And also when it comes to science, the United Nations have decided we should have a decade of ocean science for sustainable development that will just start in 2021. So lots of new science to better govern the seas and oceans. On the other hand, there's also lots of movement now to exploit the oceans even further. Of course, do it sustainably, but it's under the name Blue Growth. We should generate energy. We should grow much more aquaculture in the seas. We should also explore and exploit minerals, medicines, and many other things. So of course that's contradictory. How do we do that without degrading the services that the oceans provide? So in order to do that, of course, we need to measure and understand the state of the oceans. And there is not so easy to do because the oceans is very dynamic in space and time and depth and seasons and so on. And we only have about 300 research vessels globally that do this surveys. So in order to understand the complex system, to also follow over time, we need to observe the oceans more. And luckily, there are many new technologies and methods coming into place. We have lots of sensors that can be hanged from the dock, or it can be going up and down on moorings. We have gliders, like robots, floating along the oceans and continuously measuring up and down and sending the data back to the land through satellite communications. And satellites, we have many different new remote sensing. It's called the satellite observations that can measure the state of the sea in many ways. So all good there. How about sailing boats, sailing ships? What role may they play? Well, of course, the sailing boat cannot compete with a big research ship when it comes to transporting and deploying heavy oceanographic equipment. But we think that there are many niches where sailing boat or sailing research ship can actually be the play a role and be especially cost effective and also environmentally sustainable. So there are three levels, I would say. You could say in the sailing research ships, and there seems to be a new trend here I'd like to propose. We have the Tara Oceans, the French flagship, where they have actually been out for about 10 years and measuring both in the Arctic and in the tropical seas, and they published a lot of high impact papers in here in Nature and Science, very prestigious journals about plankton and about marine litter and the microbial life in the oceans. Really groundbreaking new science. Here we have the brand new research vessel Leopold Seibold from the German Max Planck Institute that was just launched and is now on this maiden voyage to study the ocean atmosphere interface. I think they are in the Canary Islands now doing the first test. This is now whaling research vessel from the UK. So this, I would say, a very fully professional, and it's probably here also where the Admiral Bellingshausen expedition fits in. Another way is the ocean race boats. So the Volvo Ocean Race that was had one of its legs ending here in Gothenburg, and of course it's Volvo capital. you can say, one of the boats had microplastics and the carbon dioxide sensors and samplers on board for the whole journey. So these are preliminary microplastic samplers that was taken on the race boats and analyzed in Kiel in Geomar on the way back. Sailing for Science is more of a grassroots movement. What can we scientists do in collaboration with cruising sailors, and what kind of opportunities are there to it's a low carbon footprint and cost-effective ways of doing some sensible ocean observations on small sailboats. And this is a paper showing actually from month to month where cruising sailboats are moving around the world. So there is an opportunity here for simple, you can say, citizen science tools to deploy. People really like to help and deploying sensors on their boats while they're out sailing anyway. I will give now some examples. We had one expedition in the Baltic Sea with the Rimfar sailing boat, which is a British Steel Global Challenge, 67 feet, a little bit smaller than the Admiral Bellingshausen, built about in the early 90s. We had sampling across the shipping lanes to see what kind of pollution may shipping induce to the waters in the Baltic Sea. And it was air sampling, see here, taking in air, filtering the air, and measuring lots of different gases and particles and so on. In the front of the boat, it was also a sensor stick, you could say, measuring continuously the salinity of the water, the temperature, the oxygen, carbon dioxide, pH, and oil residues. All these measurements, and additionally we took some samples. So here is a short video. Let's see if we can get that going. Leaving the south of Sweden to sample in the intense shipping lanes between Sweden and the island Bornholm. So here you see the sample intake for the air, where this goes into the lab that was temporarily built up, and in front we have the stick with the sensors, so being continuously measuring the water parameters and logging on as we go along. So of course we needed to be adapted and make use of simple tools. So this handheld water samplers taking from a fixed depth of 5 meters. And here are samples filtered for nutrients and trace metals into different sample bottles. So we had scientists from Götebourg University, IVL, and Chalmers University of Technology, and also from Germany, and some other volunteers. So here you see lots of activities, water sampling, and then we had also a mini CTD. CTD is more Leif's expertise, he will tell later, but conductivity, temperature, and depth. So to making the profile of the water as it's lowered. Now cruising along, changing the filters for the. This is not fishing. That's actually the mini CTD, the sensor that has a GPS. It does measure conductivity, that's how salt the water is, temperature, and the depth. Also various nets for particles and plankton. So I think we'll step forward. And the output of the expedition there was a poster at the Shipping and Environment Conference, and now this plans for scientific publications. This is for our colleagues in Trondheim. They made similar expedition in the Mediterranean with the charter boat that they outfitted for marine chemistry measurements of trace elements and hydrogen peroxide in the water and so on. It was quite successful results. And finally, since we're here for the Bellingshausen expedition going to Antarctica, this is a video made by a friend of mine, Stephen Wilkins, that is operating a sister ship of the Rimfar in Antarctica and Patagonia. And he found out clearly, he's been there for 10 years, that there are many uncharted waters still, many white spots on the map. There's also a mismatch between the land and where the land is uncharted and where it actually is in the reality. So he teamed up with French hydrography office, and they had some expert hydrographer on board and some professional equipment to survey hydroacoustic surveys on the waters in many of the harbors. So here they're going across the Drake Passage, and they deployed the equipment and made some tests, and then they started to survey. So this is some of the equipment. It's very, very solid steel construction they mounted temporarily on the bow. So they had a multi-beam echo sounder. It's an echo sounder that transmits in many directions, and so it's covering a wide area in one go. And they had also a very effective or very precise positioning system and the roll, pitch, and heel sensors that also necessary to do this professionally. We also had a lab installed for the purpose. This is one of the famous wrecks that the charter boats are tied alongside. So you can see that many areas were surveyed in a few weeks' time during that season when they were down there, and the output was actually official charts, since they had the French hydrographic office collaborating with it. And Stephen was telling that we'll show this video, and he's very open to if the crew is interested to connect and have any discussions of experience from 10 years working down there. He's happy to connect. I got to get a bit carried away with the PowerPoint functions. Many beautiful places. Okay, so with that, I will conclude, and thank you very much for the attention, and this on the thanks for the funding of our expedition and for the Rimfar partners. Thank you very much.